All right, just so you guys can kind of see a really in-depth, like, I don't know how anybody could make it any more clear. And yes, I'm borrowing this PowerPoint because for some reason, other people tend to explain things quite nicely. Okay. So when you're asked, this is the same problem that we had with the blue and the green here. So calculate the number of moles of phosphoric acid. So when it's asking you to find any number of moles, etc., grams, that's your desired, by the reaction of 10 moles of sulfuric acid. So this is the same problem that we just solved, but it's going, step by step here. So step one, the moles of the starting substance is 10 mole, okay? That's what you start with. The conversion needed is moles of H2SO4 to moles of H3PO4. So sulfuric acid to phosphoric acid. So we keep our desired on top, which is the 3 mole of phosphoric, which is up here. Okay, that's where we get the 3 from. We didn't make it up. It's right there in the balanced chemical equation. Over our start substance, which is right here, sulfuric acid. Now, again, common problem, people will actually put 10 down there because that's what's used in the problem, but mole ratio has to come from the equation. So we're going to use the 5 from the equation, which is 5 moles of sulfuric acid. So 10 mole times 3 over 5 will give you 6 mole. Now you'll notice the red lines crossing out. I'm crossing out my like terms, okay? If I'm crossing out my like terms, then I'm only left with the desired substance, okay? So that's why we have to worry about our units being in the right place. So 10 times 3 over 5 is going to give you 6 moles of phosphoric acid, okay? And that is that problem broken down into its 2 steps. Now it's asking you, okay, so this is next problem in the game. Calculate the number of moles of sulfuric acid. So that's our desired, that react when 10 moles of calcium phosphate react. Okay. So here's my calcium phosphate. Okay. Here's my sulfuric acid, right? So I have 1 mole for every 5 moles. So step 1 is to identify your starting substance, which is 10 mole. Okay, that's given in the problem. And then we set up our mole ratio, keeping the desired on top, which is sulfuric, over the start. So it's 5 moles. I pull that right from the problem, over 1 mole. Again, I pull that right from the problem. So 10 times 5 over 1 is going to give you 50 moles of sulfuric acid. Now, the reason why that kind of makes sense is that for every 1 mole, and this is kind of easier math that you guys can kind of see in your heads, for every 1 mole of calcium phosphate, fluoride, calcium, I don't know what that's actually called, but it's Ca5PO4 3F. So it's not calcium phosphate. I've been ignoring the F on there. So it's something with calcium phosphate and fluorine. I'll look it up later. I'll post it because it'll bother me. So for every 1 mole of that substance, 5 moles of sulfuric acid react. Okay. So if 10 moles of this substance reacts, we have to tenfold our other substance. So 5 times 10 is 50, which is why you get your answer here, 50 moles of H2SO4. Okay. I'm going to stop videos here. All right. We blitzed through 31 slides. Some of it was review, some of it's new stuff. Be cognizant of what I'm highlighting as important, asking you to remember. Okay. Rewatch the videos, walk through the video, write it out by hand. Don't just try to sit here and absorb it through osmosis. Okay. Practice is going to help. And as Mr. Korea likes to say, patience and pencils.